Chapter 7, we will explore the idea of reliability and precision in assessments. So reliability is a pretty important part of assessments because we want to know that the outcome of any kind of psychological testing or assessment is going to be reliable. So I'd like to know that if I give the same assessment to every client in my office, that all of the outcomes are going to be dependable, that they're all going to be something that I can use to make clinical decisions, that I can share with the client as something that's going to be pretty consistent. And for example, if I want to use it to measure progress, I want to know that if I give that assessment now and I give that assessment 6 months from now, it fundamentally will come out the same way. And so any kind of changes can really be attributed to potentially any kind of treatment that we've done, any kind of changes that a client has made in their life, different things that might be going on, and not just because the assessment can't be depended on over time. So this is this idea of reliability. And so reliability refers to the degree to which the test scores are dependable, consistent, and stable over time. So every time I should give it to someone else, I should be able to depend on assessments to be accurate or reliable every single time. And so the term reliability actually refers to the results or the outcome of the assessment, not the assessment itself. Talking about the assessment itself is when we get into other concepts like validity. And so know that there are specific types of reliability and precision that look at different aspects of what makes an assessment dependable. And so there are different kinds of things based on time, based on how many items are in the assessment, based on who's scoring the assessment, based on the population of person who's taking the assessment, all of these kinds of things. And in the way that these assessments are developed and reliability is determined, also note that reliability is really an estimate or an average of what we can expect over time. So there may be some fluctuation, and we'll get into this idea of degree of error in just a minute here. There may be some fluctuation, but overall, we can depend on the fact that that degree of error is going to be small enough that it wouldn't fundamentally change the outcome of the assessment, and it's something that we can anticipate and account for. Also know that in addition to the specific types of reliability, there is some degree of error, as I've said. So there's no such thing as a perfect assessment. There's no such thing as perfect reliability. And that's because we have human beings taking these assessments. So there's no way to fully anticipate every single piece of human nature and the elements of being human and therefore imperfect in the way that an assessment is conducted, scored, and interpreted, right? If we had robots or we had computers taking and scoring these assessments, then we potentially could have perfect reliability because there is no change in a computer unless somebody programs it to be that way. And I'm not talking about like assessments that you would take on the computer, because then you still have a human being typing in the things into the computer. So anytime there's a human being who's taking an assessment and scoring an assessment, there just is always going to be some degree of error because of the nature of human beings. But the good news is, in the way that we calculate these things, we can look to statistical ways to anticipate that reliability, calculate a degree of error, and then factor that out into the way that the assessment is scored. And we'll learn more about this in general, but also when we look at different types of assessments a little later in the course, we'll talk about this and what this looks like for each one, because it's a little different just based on the way assessments are structured, the type of scoring that's used, and a bunch of different kinds of factors that are involved. So again, as part of reliability, we have this concept of measurement error because we have this kind of human factor involved in any kind of assessment, either giving assessments, scoring assessments, the way assessments are even measured in the first place. And so again, reliability referring to the outcome or the score, we have to consider this measurement error because measurement error is really those changes that result from the measurement process that aren't really about what's being measured. So, for example, if I were to take an IQ test, and there was some fluctuation in scores if I took the same IQ test 3 or 4 different times. That doesn't really mean that my IQ has changed between time number 1, time number 2, time number 3. What's changed or what's created that fluctuation in scores is measurement error. So part of the humanness of the process that can be attributed to multiple different factors that we'll explore in just a moment, right? So thinking about if you were to take the same assessment 3 or 4 different times, those outcomes, those scores might change just a little bit. And it doesn't mean that I'm any more or less anxious, maybe, or depressed, or smart, or have ADHD any more or any less than I did from the previous times or in the next time that I take the test. It's just this measurement error piece. And so we have what's considered the observed score, which is the actual score on the test. So whenever I finish the assessment and I have completed the scoring protocols, that's the number I get. That's the answer that I get, is this observed score concept. And what that's comprised of is the true score, which is the actual accurate reflection of somebody's ability or skills or knowledge or symptomology or whatever it is. That's whatever the real actual answer is, plus that measurement error, that potential fluctuation, that potential margin of error, right? And so when we add the true score and the measurement error together, we get the observed score. So we might see that measurement error fluctuating from time to time, but that true score really shouldn't change if it's a reliable instrument, right? And so that's why we include both in this idea of observed score. And then we can use statistics to look at things like the standard error of measurement, which would tell me over time about how much that fluctuation was, so that I have an idea of what the true score really is over time, right? So that observed score is the actual score. The true score is whatever the most accurate score possible would be, and that measurement error is the fluctuation over time based on those human elements. So you may find yourself wondering what kinds of things might cause this measurement error that we would notice in the way that assessments come out over time. So one example of that is this idea of time sampling error. And so it's this idea that over time, there might be some small variations in the outcomes of an assessment. Again, it's not because necessarily my IQ has changed significantly in 2 weeks' time, but there are a lot of other things that could change. So think about the idea of things like test taking anxiety, right? And so if someone comes in, they sit down and take the IQ test, but they had a really bad day, or they just had some sort of significant loss in their life, or maybe they're hungry because they forgot to eat breakfast, they may not concentrate as well. They may not do as well on the IQ test. And it's not because they're necessarily any less smart than the last time they took it, but there's some other factors that are influencing from time 1, which is the first time they took the assessment, to time 2. All of these other factors came into play. So in time 1, they came in, they were feeling great, they'd had a good breakfast, they had enough sleep, nothing really major was going on or bothering them, they were feeling pretty confident, they took the IQ test, they did pretty well. Time 2, they come in, maybe their dog had just had to be put to sleep, or they forgot to eat breakfast, or they just had a really bad day and didn't sleep particularly well. And then they come in and take it at time 2, and the score decreases. Now, that doesn't necessarily mean that at time 2, they're less smart. The IQ is actually less than time 1. It's just that measurement error because of time sampling. So things happened between time 1 and time 2. There are other things that we might notice, like this idea of carryover effect. So think about standardized testing in schools, right? And usually like YTOP or other standardized testing happens over multiple days. So students come in day 1 of YTOP testing, they take their tests, they go home, they come back on day 2. Some of them might be feeling really great because day 1 went pretty well. Some of them might be feeling a little bit nervous or tired or anxious because they didn't feel like day one went particularly well, or they're really tired from day one. That would be that carryover effect. So day one of testing impacts day two of testing, even though the content of those two may or may not have anything to do with each other. So that idea of carryover effect, where the first testing session influences the score of the second testing session, even if the tests don't have anything to do with each other. Then we also have this idea of like practice effect. So if I take the same test multiple times, I'm going to do better on it because I'll remember some of the answers. I'll recognize some of the questions, so it won't take me as long to figure out what it's asking before I have to answer. I'm just going to do differently on it over time, taking the same assessment over and over and over again, right? Some of that connects with some of these ideas of validity. So there's some things that we can build into an instrument that may help counteract some of those practice effects, but they're still there. I mean, if someone think about it, if you had a math test and you took the same math test with the same questions and the same answers 5 different times, you're going to do a whole lot better the 5th time than the first time. Because not necessarily because you know the math any better, but because you remember the questions, you maybe got your answers back and you remember some of the answers. Some of it might be because you understand it a little bit better, but then we're really measuring how well you can incorporate feedback and you can learn as opposed to how much you actually know the math. So some examples of time sampling errors that can impact measurement error. So then we have content sampling error, which is if a score is supposed to tell me about my anxiety, for example, but it doesn't include aspects of social anxiety, and maybe all of my anxiety is attributed to social anxiety. If it asks about all other kinds of anxiety except for social, and then I take the assessment might say that I don't have any anxiety at all, because the content of that assessment doesn't cover the type of anxiety that I have. So this is pretty common, actually, if you think about it, where someone gives someone a test or an assessment to measure something, and it just doesn't really accurately capture what's going on. So whatever's happening for that person is just left out of the picture. It's not captured by the content of that assessment in the first place. And so that's where we talk about it's really important to take the outcomes of assessment in context and make sure that the assessments that we're using really match up to what a client needs. Because if we're not measuring the type of thing that they have going on or the type of thing that they need, then that outcome is not really going to be very helpful. And so we have this idea of content sampling error because maybe using things like scales and subtests can help with this because we can look at the relationships between different types of subscales, and we can use more sophisticated statistics to look at just certain aspects of tests and subscales, even if the overall outcome of the assessment is not so helpful. Sometimes one subscale can be very helpful to give us a picture of what's going on if that subscale really taps into what's happening for that client. So we have to be careful about the content of assessments and making sure that they match up accurately to what we need to measure for that client. So then we have inter-rater differences. And this is this idea, particularly with more subjective assessments. If 2 different people sit down to observe the same classroom, we're going to naturally notice different things. We may notice some of the same things, but there are also going to be little details that I would pick up on that perhaps my other observer doesn't, and then vice versa. They might notice things that I don't notice because it is impossible, again, this human factor, it's impossible for me to notice every single little thing that happens in a classroom if I'm trying to observe things. My attention just cannot capture everything. And so there can be some rater differences that would lead to some sorts of measurement error. And the way that we combat this is this idea of inter-rater or inter-scorer reliability. And that's part of what's built into a lot of assessments that are considered stronger. So they have hundreds of raters or observers give these assessments and score these assessments, and then they average the scores to see how much difference there is from one rater to another. And then there are different thresholds statistically to make sure that that difference between each person giving and scoring the test is small enough that it's not going to fundamentally change the outcome of the assessment. So if you're using a really good, reliable instrument, then you'll know that that inter-rater difference is small enough, that margin of error is small enough that it's not going to fundamentally change the outcome of the assessment in the first place. Then we have a couple of other sources of error. The quality of the test items. So are they written in a way that's easily understood by the person who's taking the test? This can be a common criticism of things like standardized testing, because there's a question of how much is it really measuring how much the students are growing and learning, and how much of our attention is really spent on making sure that the students can understand the questions and the way the test is formatted in the first place. The test length. So if I have an instrument with 5 questions and I have an instrument with 50 questions, the one with 50 questions is going to give me a whole lot more information than the one with 5 questions. Now, that doesn't necessarily mean that every instrument out there needs to have 500 questions, because that may not be necessary for the type of information that I need. So we look at things like the Beck Depression Inventory, it's like 10 or 12 questions. But that's all we need, because it's a screener tool that would then lead to us doing further diagnostics on depression or anxiety, right? So the test length is a factor in reliability, and also don't assume that just because something has a ton of questions involved makes it a really reliable instrument, because it doesn't necessarily. Again, this quality of test items, those different content sampling issues, you may have 500 questions, but they may not be very good questions. So it's just one aspect of reliability or measurement error. Then there are test taker variability in ways that we've already talked about, right? In talking about time sampling errors. So if it was raining and I missed my bus and I didn't eat breakfast that morning and I didn't sleep particularly well, I'm not going to do as well on my assessment. And you may not get to administer it more than once. And so we just have to factor in that the outcomes of the assessment are influenced by what else is going on in my day. I don't know that things like standardized tests in schools do a great job of that. And then there's test administration. So if I'm in a room with 200 other people, I'm thinking about like the LSAT, where you have to go and you have to take the test in this room with all of these other people. That's going to be a higher stress environment than if I got to just take it by myself. If it's hot or if it's cold in the room where I'm taking the test, or if I notice there's a really strange hum that's coming out of the lighting fixture that's really distracting to me. All these kinds of things in the way the test is administered also can influence the outcome as well. So how do we estimate reliability? So we have this option of looking at a reliability coefficient. And so in that, we're looking at groups of test scores, not individual test scores. So think of it as I've got 2 different groups of people taking the same assessment in the same types of conditions at the same time. And then I want to look at the correlation between the 2 sets of test scores. And so this is like looking at the ratio of the variance, and variance is an idea that's connected to this idea of standard deviation, or how much difference there is between the true score, which is the most accurate score, and the observed score, which is the score that includes all of these elements of human error and environmental issues and all of these things that we've talked about. So I want to know how much these things are changing among these 2 groups. So remember, when we talk about correlation, correlation goes from 0 to 100. And so correlation is scored from 0 to 1. The reliability coefficient is 0 to 100, but it's the same sort of idea, where 100 would be perfect, meaning that as one group changes, the other group changes in the exact same way, in the exact same direction. And then 0 would be that they don't move together at all. They don't change together at all. So as I'm looking at the scores from group 1, and I were to make one of those scatter plots, you remember those plots that we looked at when we talked about correlation, ideally, they would change in some sort of direction. They would either move up in the same sort of way or move down in the same sort of way, When we're looking at reliability coefficients, we're not as worried about going up or down or being positive or negative like we are in correlation. We're just looking at the direction that they're moving. And so 0 would be that if we put them all on the scatter plot, they're just all over the place. They don't have any kind of pattern. They don't move in the same sort of way at all. If it was 100, they would move in exactly the same way, point by point, from start to finish. Now, very rarely do you have a 0 or a 100. That almost never happens. But the closer to 100 you get, the stronger that correlation is between the observed score and the true score. So as the observed score changes, the true score changes in the same sort of way. Now, if the observed score changed really significantly and the true score was consistent, that means that the assessment is really easily influenced by human error, by environmental issues, by all of these different pieces of reliability that we've just talked about on the previous slide. Because the true score is consistent. The most accurate score possible, which is the true score, is consistent, and the observed score is not. If the observed score is consistent and the true score is not consistent, then that means that there's some sort of element of maybe the way the test is scored, or maybe some sort of like test that changes over time, like someone's getting used to the questions, or something is changing the outcome of the score, and it's not the intelligence of the individual or how much anxiety they have. That's not actually changing the outcome of the score. So based on all of that, we're going to determine the rate of error so that we know how much we can depend on whatever score the test has as being accurate or reliable. We know it'll be the same over time. We know that it pretty well captures an accurate picture of what's going on with a minimal amount of human error or outside factors involved. So when we're looking at reliability, we would love to keep it from high to very high. So anything from a 0.89 to a 0.90, and these are correlation scores. Those are good. Those are great. If something's in that range, we want to use that assessment because it's pretty stable. Anything that's in the acceptable range is okay. I might want to add some other assessments in. So I might want to create a battery of assessments that include some that are a little more reliable, and then I can add a couple that are acceptable so that I've got other sources of information. If something's moderate to acceptable or low to unacceptable, I probably don't want to use it unless it's like a really, really specific assessment for something I really, really need, and there's no other way for me to measure it. So looking at some other methods of estimating reliability, we have good old test retest. This one's pretty popular. So it's just this idea that if I give this test on Monday and give it again on Friday, the outcome should be pretty consistent. They shouldn't change significantly over time. So we're looking at stability over time, and we're addressing that time sampling error idea. So then we look at alternative forms. This is a way of looking at parallel or equivalent forms of a test. So whenever they're creating like updated versions of an assessment or a test, or perhaps they're doing a translation in another language for a test, they want to give those equivalent tests at the same time so we can see if they really are equivalent, if the scores come out consistently, or if there's something about this new version or this new language translation that's fundamentally changing the outcome of the assessment or the test. So this is a way of looking at that content sampling error. So then with the delayed administration, it's sort of combining this idea of alternative forms and test retest. So we want to give the equivalent tests on Monday and then give them again on Friday and see if the difference between the two is stable over time. So we're looking at both stability and equivalence together and addressing time sampling and content sampling at the same time. Sometimes it might make sense to do both of those things, to do a test retest on each one individually, then look at the equivalent forms and then put it all together to see what it all looks like. So if you have a really good reliable instrument that you're using they will have done both of those things and then put them all together as well. So then we want to look at the actual items of the assessment and make sure that they are measuring what they're supposed to be measuring. So we use something like internal consistency or split half, where I would take half of the questions and put them on a separate assessment, the other half of the questions on a separate assessment, have someone take them separately, score them, and the scores should come out at equivalent ratios. So that way we know that everything's included, that internal consistency and that content is really measuring what's supposed to be measuring. If there was stuff on there that was not relevant to the actual outcome of the assessment, so think about if there were like questions on an anxiety inventory that were about eating disorders, that half of the test is not going to score similarly to the first half of the test, which really is asking about anxiety when you use scoring methods that measure symptoms of anxiety. And so we want to make sure to address that content sampling error, that there's equivalence in terms of the different types of questions that are being asked, and internal consistency, meaning that throughout the entirety of the test, we are still asking about the types of things that we're including in the scoring at the end. So we have the Kuder-Richardson formula and the coefficient alpha, which really look at the same sort of idea as this split half comparison. It's just different ways to calculate this based on different types of assessments. So the KR formula looks at things that are kind of a true-false sort of question. They're dichotomous, meaning there's two answers. So things like put a 0 if you've never experienced this, put a 1 if you have experienced this. So thinking about like the adverse childhood experiences inventory, some of the suicide assessment inventories, those kinds of things. And then you would use coefficient alpha on something that's more of a Likert scale. And Likert scale means, you know, those questions where it's like rate from 0 to 5. 0 is disagree, 5 is strongly agree, how much you agree with this statement. So you would use something like the Cronbach's alpha or the coefficient alpha to determine the internal consistency or reliability of those types of questions. So you'll often see in testing manuals noting or reporting out the KR formula or the Cronbach's alpha for internal consistency. And again, you want to go back to that chart and make sure that they are pretty well reliable to be able to be used. But those things measure that internal consistency and address that content sampling error. And we've talked a bit already about this idea of inter-rater reliability. So give the same test to do different people to administer and then compare the outcomes and then see how much difference there is between different raters, which addresses that inter-rater reliability. So at this point in the semester, maybe you're just starting to wonder and craving the idea of making your own assessment and might be wondering, how do I make sure it's reliable? I'm sure at this point you're all just chomping at the bit to go out and create and then validate and establish reliability for your own instrument of some sort. So ways to increase reliability include increasing the number of test items. So again, it doesn't have to be 500 items just to make it a good assessment, but then we can do things like those split half comparisons, some of that content reliability measuring to make sure that the items that you're including are actually relevant and contributing towards that content reliability and internal reliability. Make sure that the items are written clearly so that they can be understood by the individuals who are taking the assessment consistently. Adding multiple choice options as opposed to subjective, like essay-based scoring items. So clearly something that's a multiple choice, there's going to be less of a possibility of human error in terms of the way it's scored, as opposed to something that's an essay that's more subjective in the way that the rater is looking at indicators of whatever it is you're measuring. The level of difficulty, so making sure that something is not too easy, but also not too hard. Making sure that it's just at the right level depending on what you're measuring. So this is going to look really different for things like aptitude, achievement, intelligence testing, as opposed to maybe like diagnostics testing or some other options around like suicidality and those kinds of things. Like we don't want it to be a terribly difficult assessment if I'm looking at things like depression or suicidality, because I want to be able to have the person taking it, take it and take it quickly. If I want to look at achievement or aptitude or a GRE or look at an SAT or look at an IQ test or something like that, the testing that's used for gifted and talented entrants, I want to make sure that it's progressively getting more difficult so that we can figure out when someone's met that threshold score. In terms of the way that someone would give the test as the rater, as the scorer or observer, I'm going to make sure that the way that they administer the test is written out really clearly. So the best assessments have really clear instructions that you can follow for both how to administer and how to score. And then ideally, if you really want to make sure that it's being done correctly by the rater, you can create a mandatory training so that someone would have to go through your training before they administer or score your assessment. And that way you know they're doing it correctly. So some of these more complex things like IQ testing, you do actually have to go through a certification process to be able to do those because they are complex and require additional training to be able to accurately administer and score those assessments.